Welcome to Touch Weight Management channel. This is Yuji Nakamura. I'd like to show you how to analyze static balance weight on this video. Static balance weight is one of important factors of touch weight, which David Stanwood found out and explained and showed us how to analyze and how to use it. We collected the old data at the previous video, practical 2. So we use relevant data from that from the list, and then analyze how we can do on this action. So we are using equation of balance to analyze static balance weight, which David Stanwood found out. This seesaw model explains the equation of balance very well. This can be downloadable from his website as on the screen. The piano action works as a lever. If the one pushes key front down, the hammer goes up to the strings. There is a certain ratio between the movement of the key and the hammer. David unfolded piano action. Then he showed us the seesaw model. The pivot point of piano action is balance hole. The pivot point of unfolded lever is here. Weapon weight sits here, and strike weight sits here. The weapon weight sits at the key ratio, and the strike weight sits at the strike ratio. So right arm of this lever has 20 grams of weapon weight at 0.5 key ratio and 10 grams of strike weight at 5.0 of a strike ratio. So totally 10 grams of weapon and 50 grams of hammer related weight is on right side. Front weight sits on the left side of the lever. To balance this lever, we need to put balance weight on the left side. In this case, we've got 60 grams of weapon and hammer related weight on the right side, and front weight is 20 grams, so we need 40 grams of balance weight to balance whole lever. David Stanwood showed us balance weight is index figure of touch weight, and moderate balance weight is between 36 grams and 40 grams. Then he wrote the equation of balance as shown on the screen. Here is the data from sample note of C4 of Yamaha C7. Then we need to rewrite to get a strike ratio as shown on the screen. The strike ratio of the sample note was 5.7. Standard strike ratio would be 5.5 to 6.0. If the ratio was more than 6.0, it is bigger side. If it was more than 6.5, it must be too big. The action may have weight problem. If the ratio was less than 5.5, it might be a little bit smaller. And if it was less than 5.0, it must be too small. You may not get sufficient aftertouch if you regulate it with standard regulation specification. So we are analyzing equation of balance of this action by Excel spreadsheet. Enter related data from the checklist. This sample file can be downloadable from my website as shown on the screen. Down weight and up weight were entered. Then balance weight was calculated automatically. David Stanwood indicated moderate balance weight is from 36 grams to 40 grams. So this action has relatively good moderate balance weight. Friction was calculated automatically from down weight and up weight. Generally, normal friction range is set at 10 grams to 15 grams. David Stanwood suggested more precisely on each note. Next, front weight is entered from the checklist. Front weight should be compared with front weight ceiling, which David Stanwood suggested. Front weight ceiling indicates capped amount to avoid inertial problem of the key stick. For example, key number 16 has a front weight of 44.9 grams, but front weight ceiling suggests 37.5 grams of that note, so this actual key stick has too much key lead. Then we see similar situation in bass and tenor samples. Mid-treble 2 samples seems almost same as front weight ceiling, so it would be okay. Next, key ratio and weapon weight were entered from the checklist. Then weapon balance weight was calculated automatically. Next, hammer strike weight was entered here. We can get strike weight index number from a smart chart or strike weight table which David Stanwood provided. These indexes of the original hammers show they are on heavier category at lower side. Strike weight index is explained at the other video. Strike ratio. This piano has very good standard strike ratio level. But we are going to change hammers and shanks, so the equation of balance may change after replacement. It is possible to analyze new equation of balance before gluing hammers to shanks. So we are going to replace hammer and how to balance a new hammer to the existing action. So we need to know, or we would better know what a new hammer strike weight is about. And so, but before gluing hammers to the shanks, we can get relatively close data value of strike weight by hammer weight plus shank strike weight. So I would like to show you how to measure shank strike weight here. So first, we measure or we mark the gluing length. This is the Yamaha, and mark 130 millimeters on the shanks here. And then measure at the marked point with a measuring jig. Measure several shanks, then use average value of them. Alternatively, use 1.8 grams for normal shank and 1.6 grams for thin shank. This is the smart chart, which is plotted hammer strike weight calculated with hammer weight and shank strike weight. You can see the tendency of proposed strike weight. It seems relatively heavy in lower and middle bass. From upper bass to tenor sections, it seems very low. Two treble sections seem even and not bad. Now we are drawing target strike weight curve. Heavy hammers can be reduced up to 1 gram. Lighter hammers can be added by around 1 gram. So strike weight of new hammers can be adjusted to red line shown on the screen. For analysis, we are taking the proposed strike weight from sample notes. These are base samples, 12.3 grams for number 16 and 12.2 grams for number 17. These are the samples of tenor section. Then these are treble samples. So we are starting analysis of this action. Our goal is to get satisfied equation of balance with number 1, suitable balance weight level, lighter, keep same, or heavier. Number 2, front weight must set less than front weight ceiling level, except both ends. Number 3, achievable smooth hammer strike weight curve with matched strike ratio. Lastly, reasonable strike ratio level with acceptable action ratio, which achieves good regulation. For this project, the customer has expected keeping similar touch weight with good responsive action movement. So I am looking at first, keeping balance weight levels similar, around 38 grams to 40 grams. Second, achieve front weight less than ceiling level. Third, adjusting hammer strike weight as analyzed. Lastly, strike ratio can be 5.5 to 5.7, even if action ratio decreases a little, and a key depth can be deeper than normal, but the customer will be able to accommodate it. So we are starting equation of balance with new parts. First, enter actual hammer strike weight, which is unglued yet. Key stick and weapon are still original. With actual down weight and up weight, we can get strike ratio with new parts now, which is 5.6, almost same as original. Next step, enter proposed hammer strike weight at next row. In this case, it is 12.3 grams. Adjust down weight and up weight until strike ratio is same as previous row. We reduced hammer strike weight by 0.7 grams, and that effect with strike ratio of 5.6. So reduction of weight from right side is about 3 to 4 grams. When reduced 3 grams from down weight and up weight, it is achieved. Lastly, we are doing proposed rebalancing. Key balancing exchanges the weight between balance weight and front weight. When balance weight is increased, front weight is decreased at same amount. Let's compare with proposed front weight with front weight ceiling amount. It's now quite acceptable amount. Conclusion of analysis of this note. This one is expected with target strike weight and 40 grams of balance weight. No ratio adjustment required. Next sample note, number 17, C#2 in base. Take same procedure. Enter actual hammer strike weight, which is not glued yet. Enter measured down weight and up weight here. We get strike ratio with new parts. The target strike weight was same as unglued new hammer and shank in this case. I'd like to try reducing strike ratio by 0.2. Because of hammer strike weight is 12.2 grams at this note, totally about 2 grams of reduction from right side of the equation. We need to decrease 2 grams from left side of this equation. So decreasing 2 grams from balance weight to match a reduction of strike ratio. We don't change front weight because we don't touch key leads yet. Now we are touching key leads for proposed rebalancing. As we bring balance weight up to about 40 grams, in this case about 6 grams, we can decrease front weight by 6 grams as well. Final front weight is now same as front weight ceiling amount, so it will be acceptable. So this note is achieved our goal with target hammer strike weight, 40 grams of balance weight, and 0.2 of ratio reduction. Next sample is key number 40, mid C. Same procedure, enter actual hammer strike weight, measured down weight and up weight. We get strike ratio with new parts. Enter target hammer strike weight, in this case 10.4 grams. Then increase down weight and up weight by 2 grams to match strike ratio as 5.7. We are proposing 0.2 reduction of strike ratio on this note. So with 10.4 grams of hammer strike weight, total reduction would be about 2 grams. Then decrease down weight and up weight by 2 grams to match 5.5 strike ratio. We bring balance weight up by 4 grams, so we decrease front weight by 4 grams. Final front weight is now 28.3 grams, so about 2 grams less than front weight ceiling. It should be acceptable amount. This note is achieved our goal with target hammer strike weight, 38 grams balance weight, and 0.2 of ratio reduction. Note number 41, C-sharp 4. Enter actual hammer strike weight unglued yet. Then enter measured down weight and up weight. We get actual strike ratio of 6.0. Next step, enter target hammer strike weight. Because right side is increased by 3 grams, left side should be increased by the same 3 grams as well. I'm proposing 0.4 reduction of strike ratio for this note to 5.6. As hammer strike weight is 10.4 grams, we are looking at 4 grams of reduction from right side of the equation. Decrease down weight and up weight by 4 grams to match 5.6 strike ratio. Rebalancing. Add 3 grams to balance weight. Reduce 3 grams from front weight. Final proposed front weight is now at acceptable level. This C-sharp 4 is achieved our goal with target hammer strike weight, 38 grams of balance weight, and 0.4 of strike ratio reduction. Note number 64, mid-treble. Take same procedure. We get this result. This note is achieved our goal with target hammer strike weight, 38 grams of balance weight, and no strike ratio adjustment required. Note number 65. This note needs 0.2 of strike ratio reduction, along with target strike weight and 38 grams of balance weight. With these samples, we get now what we are doing with this action. We will adjust to 40 grams in bass and 38 grams tenor and treble for balance weight. Front weight will be 0 to -2 grams from front weight ceiling. Hammer strike weight will be close to proposed curve. The strike ratio will be around 5.5 to 5.7. So we've found out what we can do to work on this action. Next video will be shown analysis of inertial side of touch weight. Looking forward to showing you.